Hello, everyone, and welcome to the TDWI webinar program. I'm Brenda Woodbridge, and I'll be your moderator. For today's program, we're going to talk about modernizing the analytics data pipeline. Our sponsor today is Qlik. For our presentations today, we'll first hear from Jim Kobielus with TDWI. After Jim speaks, we have a presentation from Anand Rao with Qlik. But before I turn the time over to our speakers, I'd like to go over a few basics. Today's webinar will be about an hour long. At the end of their presentations, our speakers will host a question and answer period. If at any time during these presentations you'd like to submit a question, just use the Ask the Question area on your screen to type in your question. If you have any technical difficulties during the webinar, click on the Help area located below the slide window, and you'll receive technical assistance. If you'd like to discuss this webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweet. And finally, if you'd like a copy of today's presentation, use the Click Here for a PDF line there on the left middle of your console. And we are recording today's event, and we'll be emailing you a link to an archived version so you can view the presentation again later if you'd like, or feel free to share it with a colleague. So again, today we're going to talk about modernizing the analytics data pipeline. Our first speaker is Jim Kobielus. Jim is a veteran thought leader, industry analyst, consultant, author, and speaker on analytics and data management. Over the past 3 decades, Jim has held analyst positions at Futurum Research, Wikibon, Forrester Research, Current Analysis, and the Burton Group. He also served as Senior Program Director, Product Marketing for Big Data Analytics for IBM, where he was both a subject matter expert and a strategist on thought leadership and content marketing programs targeted at the data science community. At TDWI, Jim focuses on data management, which encompasses database platforms, data governance, data integration, master data management, data ops pipelines, and more. Jim, I'll turn things over to you now.
Thank you, Brenda. Hello, everybody. It's a pleasure to be presenting this webinar today with Qlik. And we'll be discussing the challenges, but also the opportunities when you modernize your analytics data pipeline. So what we're going to be talking about is really, what does it mean to modernize your pipeline for analytics and data? Of course, it involves migrating to a high-performance cloud, but it also involves taking your data engineering processes, often known as data integration or data ops processes, and unifying them, automating them to a greater degree, often using either model-driven or machine learning-driven approaches, accelerating them through a low-latency end-to-end architecture, and augmenting how your data management staff manages and oversees the ingestion, transformation, cleansing, and governance of data sets. So what we'll talk about in this order is, first of all, I'll describe what are the chief challenges and how do you migrate data to a modern cloud data platform. Following that, I'll be discussing how you unify your data ops or data engineering pipelines in the cloud, as well as automating your data engineering workflows. What are the key approaches for doing that, and where should you implement automation within this pipeline? How do you accelerate your workloads for data preparation and so forth in the pipeline? And then how do you augment the productivity of your data management teams using embedded machine learning and model-driven approaches? Before we get to that, I'm going to conduct a little poll here of the audience. So feel free at any point as I'm going through this to enter your responses. You can select one or more of the following. The question we have for the audience is, what modernization initiatives are transforming your enterprise analytics data pipeline? Like I said, you can select one or more of the following. Are you automating ETL and other pipeline workloads through model or machine learning-driven approaches? Are you accelerating analytic pipeline workloads through stream computing or other low-latency approaches? Consolidating data and analytic assets from multiple legacy databases to a target cloud platform? Are you unifying your data warehouse and data lake in the cloud? Are you building a virtualized cloud data fabric? Are you augmenting your data ops team's productivity through the use of cloud data catalogs and rich metadata? So submit your answers. I'll give you just a few more seconds here. and then we'll see the results. Well, look at this. The audience is doing pretty much all of these things as part of your modernization of data analytics in your pipelines in the cloud. A solid 72% said that you're consolidating your data analytic assets from multiple legacy databases to a target cloud platform of one sort or another. A good 44% are automating your ETL and other pipeline workloads. A good 44% are unifying your data warehouse and data lake in the cloud. We often call that a data lakehouse project or approach. And a good 28% are accelerating your pipeline workloads through stream computing and other low latency approaches. And 1 in 5 of you are augmenting data ops team productivity through cloud data catalogs and rich metadata. Okay, so let's move on now to the bulk of my presentation. Why should you migrate your data analytics to the cloud? Well, in many ways, you know why, because it's pretty clear that the cloud is a unified target for all of your data and analytics. You can you have the scale, you have the ability to handle a variety of structured and unstructured data in the cloud, as well as you have the velocity through embedding of machine learning or of stream computing and in-memory architectures in a cloud environment. So the cloud really is the unified platform for open access to a wide range of data and a wide range of analytics. And the cloud really is the target increasingly for enterprises that want to consolidate their data into a unified warehouse or lake with conformed dimensions and so forth, so you can have the data be more consumable, in lots of senses, being available on demand through self-service business intelligence, analytic and data science tooling and so forth. The cloud is very much an efficient, resource-efficient approach for being able to scale up and scale out your data and analytic workloads. And the cloud is scalable, really to the, beyond the petabytes to the zettabytes and beyond. And the cloud is accessible to one and all through open interfaces, ranging from SQL to various cloud native APIs and so forth. So really, why migrate your data analytics to the cloud? Well, the cloud is the optimal target platform for pretty much all enterprise applications and all data-intensive enterprise applications now. So really, when you talk about migrating data to the cloud, it can mean a lot of different things. There are a variety of target cloud architectures that one can be migrating your assets to. But really, what it starts out with is legacy databases, quite often on-premise, that you're migrating to a cloud architecture in a variety of ways. But some of the core tasks in any migration are being able to copying data to the new target platform, being able to having to revise data schemas to be able to conform them to the necessary format for the target platform, rewriting stored procedures, tweaking query plans, developing complex joins, building new transformations, changing database drivers, and so forth. A lot of tasks involved in any migration of data and analytics to a cloud environment. So migrations are complex initiatives, and increasingly, because of the great advantages of cloud computing in terms of scale and speed and the consumability of these assets, ultimately in a target cloud platform, many enterprises are going there. In fact, our TWI research has shown that a substantial number of enterprises are migrating to one target platform or another as their strategic objective for data and analytics. Whether that target platform in the cloud be a data warehouse or a data lake or a data lakehouse, which is a combination of a data warehouse for supporting structured data for decision support, business intelligence reporting, plus a data lake for unstructured and semi-structured data for text analytics, natural language processing, a lot of machine learning. There's virtualized data fabrics in the cloud where you don't necessarily have to physically move the data to a new target database, but rather you can provide a unified roll-up behind a unified data model and unified access to all of that disparate data behind a virtualization fabric. There's also the notion of a data mesh. We're seeing more of an uptake for data mesh architectures, which are radically distributed in terms of storage and computation and governance of data in the cloud. There's a wide range of cloud architectures that you might be migrating your data to. So what modernization means for you, it might mean any of or some blend of those approaches as a target architecture that serves your particular needs in terms of your need to speed queries and facilitate more flexible modeling and exploration of data, your data assets that might increasingly be distributed across diverse databases and storage devices throughout multi-clouds. Migrations might have various and do have various target architectures, but quite often the modernization initiatives come down to several overlapping objectives when we're talking about bringing data and analytics to the cloud. First and foremost, we often see enterprises wanting to move from a legacy on-premises database to a target cloud database of a different type, from a different vendor or a different open source software distribution and whatnot. So quite often a migration involves moving data sets, analytic apps, server objects, and other assets to a different sort of platform in the cloud, a different sort of data platform. A migration might have optimization of one of its core objectives, which is to rebalance assets, storage, and computation across disparate cloud platforms to enable a greater degree of efficiency and perhaps a speed and throughput in terms of the processing of data and analytic applications. That's often, optimization is a key goal of migration projects that involve moving to a multi-cloud or to a mesh or to an edge or even a hybrid cloud architecture. It's to be able to improve performance by rebalancing the distribution of data and analytics across disparate clusters and servers and clouds. Also, consolidation. A great many modernization initiatives, migrations, involve consolidating your data sets, your store procedures, and other analytic assets into a unified cloud database, what's often called a lakehouse, so that you can provide a unified roll-up, a unified query, and unified visualization and modeling of disparate data from different sources. Quite often we see that as one of the key enablers for a new generation of artificial intelligence and AI-driven applications that need to combine disparate data sets but provide a unified way of not only viewing but exploring and modeling this disparate data so it can be built into a wide range of downstream applications. So when we talk about modernizing your analytics data pipeline, first and foremost, it comes down to unification. Really, it's simplifying access to and expanding visibility of disparate data and analytics assets behind a unification front end. It may be a target cloud data platform that you're moving all these assets to, and then providing unified access through SQL and various APIs. Unified access to both business users as well as data scientists and business analysts to be able to not only view but to be able to build and train machine learning models from that unified data. So there's the unified view of all these assets. A unified data ops and ML ops pipeline is absolutely essential for many migrations, meaning as more and more of your users become self-service data scientists, and even if they're professional data scientists, what they need is a unified backend that handles all the data preparation, ingest and discovery and preparation, as well as a unified set of engines to handle the modeling and training and inferencing needed to build out high-powered data applications. So also, unification usually involves providing a unified experience to all users to help them in a simple, consumable way to access, to analyze, manipulate, and process all of that data using models that they built or pre-trained models that they are training in the cloud. Often unification involves unified management, unified monitoring, and unified optimization of all those disparate analytic workloads, using a new generation of tooling that enables you to flexibly, but also comprehensively view and optimize the status of various data analytics jobs within that unified pipeline. Unification usually involves an abstraction layer for programmability of data and analytics as cloud-native microservices. We see at TWI a wide range of enterprises that are exploring different abstraction frameworks, virtualization frameworks, serverless APIs, and whatnot. There's a broad range of abstraction layers that one might use and APIs that one might use to unify programming of back-end cloud data analytics services. Automation is a key part of this, of many migrations of data and analytics. Really, your distributed, scattered data analytics, to be able to explore, to be able to process it all, to be able to view it all in a unified way, to be able to manage governance and stewardship and so forth of data that's bulking large into the petabytes and beyond. Increasingly, you need automation built into the pipeline, everywhere from data ingestion through data transformation, ELT, data profiling, data warehousing, and whatnot, to be able to automate more of these functions so that human beings can, meaning your users and your data scientists and your analysts, they can work with growing volumes and varieties of data in a fairly seamless way. So model and machine learning driven approaches to automation have taken hold in unified pipelines. And really, automation comes in when you're, when you're validating the data that's being ingested, when you're looking for patterns, but also anomalies in pipeline traffic, so that you can set up automated remediation jobs to be able to fix any issues before they become showstoppers. It's all about correlating pipeline events. Automation increasingly allows you to unify observability of different events in the pipeline to get a good sense for the status of jobs, data cleansing jobs, data augmentation jobs, and the like. But also, automation using model and machine learning driven approaches is key to identifying root causes of issues in terms of bottlenecks and delays within the pipeline, within the data preparation pipeline, within the model training and optimization pipeline, and so forth. Automation is critically important for remedying any pipeline issues automatically, or limiting the need for expert data engineers to come in and fix bottlenecks and glitches in the flow and processing of your various data analytics jobs. Automation is very important for being able to optimize the workflows that are involved when you're building and managing ETL and other jobs in the pipeline. So in many ways, automated ETL scripting and adaptive ETL is becoming a standard practice in the cloud data analytics world. And where it comes down to augmentation is that model and machine learning driven approaches are critically important for guiding your data engineers and your data stewards with embedded inline recommendations about how they should do their jobs in terms of what issues are cropping up in the pipeline, what they might need to do in terms of fixes and workarounds for any issues that may be popping up. So in many ways, in contextual recommendations to data engineers and others in terms of how to manage data analytics workloads are critically important. And so what we're seeing now is that more and more data ops tools provide embedded automation to help your teams of data engineers, data scientists, DBAs, and whatnot to do their jobs more effectively, because otherwise it would just overtake them as just the complexity of cloud environments is growing by leaps and bounds, and the the degree of the stakes involved in delivering high quality data analytics to the business demands that you automate these functions to the maximum extent possible. So in many ways, data and analytics are flowing fast and furious throughout the pipelines of the business world. So what we're seeing now as you unify your data analytics pipelines, as you automate them, you're also accelerating them through a wide range of approaches that have become standard in the architecture of data analytics pipelines. Stream computing, no-copy data management, query plan optimization, change data capture, in-memory, scalable parallel processing, near real-time stateful computation. There are a wide range of approaches that are involved in providing a low-latency real-time cloud environment within your data analytics pipeline. And augmentation, as I've indicated, your data engineering, data ops teams, in order to do their jobs effectively, they're relying on machine learning and model-driven augmentation and embedded recommenders within the tooling that they use. One of the key aspects of automation, but also augmentation, is providing your data teams with searchable data catalogs and other observability tools in the cloud to help them to be able to manage disparate data sets, machine learning models, analytic objects, and so forth in a unified way. Really, a data catalog is a key piece of the infrastructure that helps your data teams to, for example, your data engineers, to figure out how to build highly efficient ETL jobs. The data catalog enables your IT professionals to visualize the alternative price performance of various data ops architectures as they're building them out. The tooling can help your data stewards to figure out how to spot any data quality issues before they become impactful on downstream, like business intelligence applications. Your data catalog, it can be a key enabler for your data architects to help them to identify any cross-system data dependencies among linked business processes, so that a bottleneck in one process, the risks to other linked processes can be mitigated. So there's a lot of different things that a searchable data catalog and other observability tools can provide to your data teams to help them do their jobs more effectively. And what this involves for augmentation is not just a data catalog, but it's strong tooling for data quality, data cleansing, but also for metadata management and profiling and visualization. And with open APIs that any observability tool can plug into to be able to be used by these technical and business professionals to do their jobs more effectively and really to find patterns within the data as they're building out jobs, but also as they're monitoring successful execution of these jobs in the cloud. So when augmenting the pipeline with comprehensive observability, it's good to focus on the fact that visualization, APIs, data catalogs, these are all critically important, and really what they drive is downstream monitoring with embedded closed-loop remediation of issues with the performance of the pipeline itself, and any issues with the quality of the data and the machine learning models that are being built and delivered through this pipeline. Your observability tooling should be platform agnostic. It should be able to monitor data and analytics that are executing anywhere in the pipeline. It should be, of course, low latency, on demand, and real time, because data lives in real time. Analytics increasingly plays into real time interactive applications in the business. So you have to be able to observe and predict issues before and deal with them before they can become critical. Observability is critically important. It needs to scale and adapt to the end-to-end topology and distribution of data throughout your multi-cloud or cloud-to-edge environment or your hybrid cloud. And you need to have automation built in so that the data cleansing, data quality rules can be adapted to fit the new data sources, but also the new stewardship and compliance requirements for the data. And all of these assets need to be visible, observable through open APIs with configurable alerts that are sent to the different stakeholders to help them manage the pipeline from end to end. So when we look at your analytics data pipeline, modernizing it involves, first and foremost, migrating to a cloud architecture, consolidating your pipelines, MLOps and data ops into an end-to-end streaming low latency automated environment that can help distributed data management teams to do their jobs more effectively. We can also provide them with contextual intelligence on how to manage the pipelines and how to manage the data and how to manage the analytics jobs on an ongoing basis. So really, modernizing is all about building an end-to-end pipeline that can manage all data and all analytic assets all the time and provide the necessary intelligence to all the stakeholders all the time to help them do their jobs so that you can continue to scale your analytics data cloud architectures without worrying about it all falling apart, but rather the automation that's being built in will help you to continue to scale out these assets to serve a growing range of business requirements. So with that said, I'm going to thank you. I'm going to hand it back to Brenda, and then she'll have Anand Rao from Qlik.
Great. Thank you so much, Jim. And just a quick reminder to our audience, if you have any questions, you can enter them at any time in the Ask a Question window. I will be answering those audience questions in the final portion of our program today. But yes, it is now my pleasure to introduce our next speaker, Anand Rao with Qlik. Anand is a product marketing director for Qlik Data Integration. Anand has over 20 years of experience in data management, working with Informatica, Pentaho at Hitachi, IBM, and Embarcadero. Before his marketing role, Anand worked within engineering, developing data integration software. Anand lives near San Francisco and relishes being enveloped by technology. Welcome, Anand.
Thank you, Brenda. Hello, everyone. I'm very glad to be here. As Brenda mentioned, I'm a director of product marketing at Qlik. I'll be adding to Jim's narrative and talking about how you could modernize your analytic data pipeline architecture, the trends that we are seeing at Qlik as we look at our market and we look to our customers and prospects, and we can analyze those trends and see what the customers are seeking. So with that, let me begin by asking a quick poll question. Many of you here are data engineers and data architects. So while you're considering your modern analytics data pipeline, which of these technologies are you considering? Are you considering a streaming platform such as Confluent or Kinesis or Google PubSub or Microsoft Azure Event Hubs or some other similar technology for streaming? Second, a big data processing platform based on Spark, such as Databricks or Cloudera or some other similar platform. Are you considering a cloud-native data warehouse, such as Snowflake, Microsoft Azure Synapse, AWS Redshift, Google BigQuery, or some other similar cloud-native data warehouse? Are you considering an object storage system, such as AWS S3, Google Cloud Storage, Microsoft's Cloud Storage, or some other system? Are you considering a cloud database, such as Google Cloud SQL, Azure Database, or Amazon RDS? So this is a multiple choice question. So as you think about the different components in your architecture, it'll be great if you could check off which ones you're considering and which ones you have in production right now. So this will give us a feel for the audience, and I could tailor my talk accordingly. So maybe we'll wrap this up in 5 seconds. All right. So great responses here. Definitely people are looking at a cloud-native data warehouse such as Snowflake, Synapse, or Google BigQuery. The next popular item that is on everyone's plate is a cloud database. That's interesting. Google Cloud SQL, Azure Database, Amazon RDS. And the third one, which is not a surprise, you got the data lake side of the house with consideration for Databricks, Cloudera, and so on. And then finally, you've got the object storage, AWS S3, Google Cloud. And then finally, at the last, you have a streaming platform such as Kinesis, PubSub, or Event Hub. So that's a real good insight on what your peers are looking at and the different technologies they're considering. So as I said, my discussion today is about modernizing your analytics data pipeline. We'll go through it from a conceptual perspective, and this will be in alignment with what Jim just spoke about. And then we'll go dive deeper into the specific technologies that could be part of this architecture, as well as some of the customers that have used these architectures and the benefits that they have got. So let's dive in. So these are some statistics from the industry. After billions of dollars of market investments in data and analytics solutions, enterprises have only achieved limited results. Surveys conducted by prominent research firms of IT leaders showed the following. Less than half, 44% to be accurate, of organizations believe they have access to enough data to make their decisions. Only 29% of executives feel they achieve transformational business outcomes using that data. And around 35% of executives see poor data literacy as a critical roadblock to change. But it does not need to be this way. And the value achieved by getting the analytics data pipeline right is tremendous, with 75% of those surveyed enterprises seeing improvements in their operational efficiency, their revenue, as well as their profit. So let's talk about some of the challenges as we talk about analytics resulting in less than satisfactory results. The biggest challenge that we face is, on one hand, we've got teams of people in data engineering that are typically responsible for delivering the right data to the business. On the other hand, we have groups of business users who are always clamoring for data in different formats, resulting in only about 44% of the data they need being available to them on time. So this results in a huge gap in communication between these two groups of people. So our vision is to close this gap. And when you close this gap and make data available to the business users, that's where the business value comes from. And a lot of times we find, especially in big organizations, on the data integration teams, you've got people who are responsible for ingesting the data. You've got teams responsible for the transformation of the data. You may have a different data warehousing team. So you have silos of teams. You could have multiple business intelligence tools on top of that. And with the advent of predictive and prescriptive analytics, you have data science teams needing data at a much finer granularity, resulting in further silos. So you need to close this gap between all these different silos and deliver that business value. So we get to the first gap, and we need to close this gap by freeing that data. We need to unlock this data from all the source systems in our organizations, especially the hard ones that are doing the bulk of the transactional processing. It may be SAP, it may be mainframe, maybe big Oracle farms. We need to unlock this data from all these different heterogeneous systems and deliver it in the right format. Second, you need to make this data analytics ready so that business users can find this data. And the way they find this data is through a rich data catalog. The catalog preserves the lineage of the data and smartly identifies the data so that users can shop for the right analytics-ready data. Next, we are at the stage of the analytics data pipeline where users can begin to understand the data. Users should be able to take the advantage of the power of descriptive, prescriptive, and predictive analytics to uncover rich insights and outputs. So at that point, the business is ready for the data, meaning there's business logic applied to the data. So what we really want is to take the insight to action. And actioning this is around the alerts and automating that process. When we find something interesting in a business moment, how do we take advantage of that and bring it to action? So these steps of freeing the data, finding the data, understanding it, and acting on the insights from that data comprises the analytics data pipeline. So one of the things that you'll see woven through the pipeline to make it really function powerfully is automation, automating every step. We are not just ingesting this data and moving data into the cloud. We've got heterogeneous sources and we've got different target systems. We want to automatically map these different systems and their different schemas and move the data continuously. We want to refine and generate analytics-ready data in a warehouse or a lake or an operational data store or an historical data store. We want to automate this entire process. Next, we want to augment it with analytics tools where business users can ask questions of the data and derive insights in an automated way. And once they find an interesting insight, we must automate the process of acting on that insight, whatever that action might be. An action could be we found our organization's most valuable customers taking advantage of a certain offer that we are promoting. We want to change the marketing score in our marketing automation tool. Maybe it is Marketo. And we want to change it to result in higher quality leads progressing through the funnel. We want to take this action of augmenting the lead score directly within the dashboard and move forward in an agile fashion. So that's how we have real-time data and create these analytics data pipelines to transform the business. And these automated modern analytics pipelines lead to our vision of active intelligence. We are moving from passive business intelligence, where we ask questions of the data, to a more event-driven active intelligence. We want the pipeline to not only tell us what's happening, but make it happen in real time. We first free the data, unlock it from wherever it resides. We then find that data as a business user and have confidence, understanding, and trust in that data. We serve up the insights that we need to truly understand the business and then act on those insights in real time. And this is what we mean by active intelligence. So let's translate this view of active intelligence and the analytics data pipeline into the technology and the services involved. Where does Click live in this new modern world of cloud and digital transformation? How does Click work with the hyperscalers to bring all this data to the cloud? So on the one hand, we have Microsoft, Amazon, and Google, who all offer their different services and platforms. They rely on Click data integration to unlock this transactional data and bring that data to the cloud in real time. Next, we have best-of-breed technology platforms that are independent of these hyperscalers. Confluent with their engine for Kafka, Databricks with their Spark engine for big data, Snowflake with their cloud-native data warehousing platform. They all rely on Click to bring both on-premise data and cloud data to them. So Click is a top technology partner with all these hyperscalers and even the best-of-breed technology platforms that we have listed here. And we can transact in all their respective marketplaces, resulting in seamless transactions. So our customers value us because in addition to bringing data from traditional operational systems, we bring in previously locked SAP data, mainframe data to their platform without extensive services and without impacting the load on these transactional systems. The second value is the power of our professional services partnerships with global system integrators. So there are huge system integrators such as Accenture doubling down and working with us to deliver this end-to-end vision. There is this myth about SaaS platforms that it's easy, that it's taking away the complexity. As you look at this slide, all the hyperscalers offer their own cluster of services and elements that adds to the complexity, and enterprise customers today want guidance on the journey to the cloud. They want to understand which services go where does Kafka, Kinesis, PubHub fit, and the complete technology stack that is available to them. So if the vendor were to unlock SAP data and stream that through the business in the finance functions, for example, the CFO within that leading organization can add a lot of value. That really is critical to understanding and seeing the benefit of bringing together a Click data integration and Click data analytics to drive business value. They help customers understand the value of streaming analytics and how that is derived from using Spark as a service or a lakehouse or other technology elements independent of where the data resides. So given that technology background and the conceptual view of the analytics data pipeline, here are 3 examples of enterprises who have benefited using Click. Urban Outfitters is a lifestyle retailer selling women's and men's clothing and accessories, a range of items for interior furnishing, and a decor and music and technology collection. So their challenge was that their data was siloed with many different systems and technologies across 650 of their stores and only available to the store managers of those specific stores. And this was coupled with time-consuming and complex store reporting based on old data. And this, in addition, was further compounded by the management of store closures during the COVID pandemic. So with Click data analytics and Click data integration, they reduced the time for the store managers to run a report from 2 hours a week to instantly available. At the same time, they improved their global performance with every employee aligned to the in-store metrics and the new purchasing patterns that resulted from the pandemic. They also reduced the stress and costs of managing on-premises data sources. So how did they do it? They consolidated 3 previously separated reporting locations into one central cloud hub with Snowflake cloud fed by Qlik data integration. They had streams of around 50 gigabyte of data per day from on-premises data sources being streamed into the cloud. They scaled up access to more real-time data for their in-store employees and developed over 240 Qlik applications in the cloud for insights and a range of KPIs, such as store performance, e-commerce sales, operations, distribution centers, and supply chain logistics. So they got the entire gamut. They were able to react in real time. So here's another customer, our second example customer. This is Green Tweed, who's a leading global manufacturer of high-performance thermoplastics, composites, and other engineered components. So their challenge was to provide speedy access to data and ensure that every decision they took is the right one while increasing revenue and driving down cost. So with Qlik data integration and Qlik data analytics, they were able to support rapid action on their KPIs, yielding predictive analytics with a 90-day accuracy of more than 95%. At the same time, this has helped support their corporate goal to be a data-driven company by 2030 and improve their real-time decision-making. How did they do this? They built an end-to-end data pipeline that transfers information from SAP into Microsoft Azure Synapse. Their analytics use replicated data in a warehouse along with near real-time data. So they developed a robust portfolio of 50 QlikSense apps with alerting capabilities to identify potential problem areas. So that's how they got the benefit of using the real-time capabilities within Qlik. And the final example that I wanted to talk here, our third example customer, if you will, is Harman International, who's a global leader in connected car technology and other audio innovations within the cars. So their challenge was that they were facing significant global supply chain volatility and fluctuating demand as a result of the pandemic. Anyone try to purchase a car nowadays will know about this. So with Qlik data analytics and Qlik data integration, they achieved a gain of 15 times faster productivity, reducing their forecast time from 2 weeks to 90 minutes, while enhancing their accuracy and improving customer fulfillment and on-time delivery by taking inventory of data in real time rather than every 3 hours. How did they do this? Working with Qlik, they built a new data analytics solution on a robust, scalable platform that quickly provided data integration, aggregation, visualization, and self-service capabilities for their global supply chain. This new solution helps over 600 users actively use the platform and manage a 360-degree view of supply and demand fluctuations, and this platform is attributed to a 30% increase in sales due to the real-time insights that they got. So if you would be interested in learning more about these customers or the host of other customers that we have, do join us at Qlik World. So you'll learn more about how automation closes the gaps between data, insights, and action to deliver informed action. So please join us. It's a virtual event beginning on May 17th until May 19th. We'll have many sessions for different audiences, ranging from the CIO and CDO to the data engineering team and their leaders, and the business intelligence team and their leaders. So we have our registrations open. And so with that, if you can't make it for this online event and are interested in learning more, please check us out at click.com/data integration. Now, I'd like to turn it back to Brenda from TDWI. Brenda?
Great. Thank you very much, Nan. Lots of great information. And we will now go ahead and get to some of our audience questions that have been coming in. I'm going to go ahead and start with this one for Anand, and then Jim, if there's anything you have to add to these back and forth between the two of you, feel free to jump in. So we'll start with this one for you, Anand. Someone is asking, what is the main difference between change data capture and doing incremental loads?
Yeah, that's a good question, and thanks for bringing this up. So while doing incremental loads, you are persisting that change data in an intermediate location. So this is typically because while doing incremental loads, you don't have the permission to access the database redo logs, or you don't have the ability to do so. So that intermediate location, while it's a good workaround, raises some security concerns that you have to take into consideration. On the other hand, in change data capture, you're doing point-to-point replication without any intermediate location. So also with log-based change data capture, you're having a minimum impact on the source systems. So that's essentially the difference between the two.
Thank you. Jim, anything else on that? I guess that one was pretty straightforward, right?
Nothing to add. That was from an authority. Yes.
Very good. So this one specifically, Anand, this one's someone's asking something specific about your product info. So there's asking, most of our transactions are on SAP on-premises. We're looking at having SAP instances in the cloud. Do you support SAP on-prem only, or do you also support SAP in the cloud using HANA?
Yeah, that's a good question. So good they are looking at SAP HANA in the cloud and modernizing their pipelines. So for customers looking to simplify their SAP HANA rollouts, either to the cloud or they're expanding their instances on premise, Click Data Integration offers accelerators. So these accelerators simplify the testing and reduces your infrastructure requirements. And using the Click Data Integration product, you basically improve developer productivity by making the configuration and creating subsets of master and transactional data much easier in these test environments, while at the same time masking any sensitive data that you may have. So that's pretty much how we improve the time to deployment of SAP HANA rollouts.
Perfect. Another one for you. Someone's asking, you briefly mentioned your integration with Snowflake and Databricks. So assuming these are targets, what kind of automation are you able to do at these targets?
Yeah, that's good. Yeah, this also aligns with the poll question answers that we got. So Snowflake and other cloud data warehouses was on top of the list. And Databricks and Cloudera, though not second, was a close second compared to the cloud databases. So glad that someone brought this up. On the Snowflake front, Click Data Integration has this product Replicate that can continuously ingest data from multiple sources to the Snowflake data warehouse. Click Compose automates that design, implementation, and management of these data warehouses and data marts. And in many cases, completely eliminating the ETL coding and other scripts that are needed. So the Qlik catalog, that's the third component that we have within Qlik data integration, can catalog these analytics-ready data within Snowflake and publish those data sets for a business analytics tool of your choice. It could be Qlik Sense or some other tool. So on the other hand, on the Databricks front, we use the same product, Qlik Replicate, that enables you to ingest data from a variety of different transactional systems into the Databricks Delta Lake. Then next, Qlik Compose, part of this suite of products, automatically merges this data and changes it into a flexible Parquet format and structure while retaining this full history and lineage. And using that, the Qlik data catalog is able to create a data marketplace from all the available analytics-ready data in the data lake. So that pretty much is how we support both the data warehouse as well as the data lake in the cloud.
Great, thank you. Got more questions flowing in, so we'll get through as many of these as we can in the next couple minutes. Someone's asking, if I'm on a single cloud, why would I not use the native tools provided by the cloud vendor instead of third-party offerings?
So Jim, do you want to take that?
Well, the third-party offerings might allow you, for example, to be able to have visibility into data and into analytics jobs in a variety of clouds. You might have a multi-cloud or a hybrid cloud or even a mesh cloud environment that you're trying to, that is the core of, or is the substrate for your pipeline. So the third-party tools might provide a comprehensive observability that a single cloud vendor's own observability tool lacks, for example. Is one example of why you may go with a third-party product.
Yeah.
Great. Thanks, Jim. Let's see, we'll go on to another one here. Someone is asking, are APIs the most common method for extracting data for cloud sources? Does Qlik data integration have API connectors? So maybe Jim and you both can weigh in on that first part of it maybe, and Anand answer the second half, or however you guys would like to do it.
Yeah.
Well, of course, there's SQL, and there are APIs. Go ahead, Anand.
Yeah, so there are several ways that you can extract data from the data sources in the cloud. And it all depends, as I said before, on the permission that you have, as well as the actual capabilities that are exposed by the individual data source. So for example, in SAP, we can go directly to the HANA database, check out the redo logs, and take the updates from there. Or if the permissions aren't there and the administrators are not comfortable giving permission, then we can go to the API level and draw the data from there. So we have, for many of the data sources that we support, there are multiple ways we can get to the data. So it all depends on the availability of permissions and the trade-off that you want to make with the performance.
Great. Anything you have to add to that, Jim?
No, that's good.
Great. Well, and with that, on that note anyway, we have unfortunately come to the end of our time. We won't be able to get to any more questions, but thanks to our attendees for submitting those. So let me just take a moment to thank our speakers today. We, of course, heard today from Jim Kobielus with TDWI and Anand Rao with Qlik. Also, thank you again, of course, to Qlik for sponsoring today's webinar. Please remember that we recorded the event and we'll be emailing you a link to an archived version of the presentation. Feel free to share that with colleagues. And also, if you'd like a copy of today's presentation slides, use the click here for a PDF line. Finally, I want to remind you that TDWI offers a wealth of information including the latest research, reports, and webinars about BI, data warehousing, and a host of related topics. So I encourage you to tap into that expertise at tdwi.org. From all of us here today, let me say thank you very much for attending, and this does conclude today's event.
Thank you all.